Hi. Okay, so this is the next question. This is review exercise M1. By the way, this is M1 old book. Okay. So M1 old book review exercise question number 47. This is the last question in review exercise 2. Okay, review exercise 2, question number 47. So they said in this question, the vector I and j are horizontal unit vectors in the directions due east, north. Okay. Two boats A and B are moving with constant velocities. Boat A moves with a velocity this much. So boat A, this is the velocity, and boat B, this is the velocity. Now, find the bearing of boat B. Okay. So whenever we have to find the bearing, the first thing we should do is always draw a diagram. And bearing is for bearing, the vector which you are supposed to take is the velocity. Okay. Never take position vector. Always take velocity vectors. So they said 3i plus 4j. So it's going to be 3i. So let's say 3i is over here. This is your 3i, and let's say this is 4j. So most probably this is where it is. Okay, if you somewhere over here. Okay, so let's draw a diagram. Okay, now the angle, this is what they're trying to find, the bearing, right? This is what they're looking for. Bearing is always from the north. So this is north, and this is the bearing they're looking for. They're looking for this. So if I can find this angle and minus it by 90, I will get the answer, because this whole thing is 90 degree. So how much is it? Opposite. Opposite is 4, adjacent is 3. So opposite of an adjacent is 10. 10 theta is going to be opposite. That is going to be 4. Upon adjacent is 3. So if we do that in the calculator, 10 with inverse of 4 by 3. 10 inverse of 4 by 3, close bracket, 53.13. Okay, 53.13. And if we do 90 minus 53.13, because I told you we need this angle. This is the bearing we are looking for. Okay, so 90 minus answer is 36.87 degree. Okay, so 36.87 degree is your A part. Now let's talk about B part. So let's change the color. In B part, they said at noon A is at point O. Whenever they say the word point O, it actually means origin. Whenever they say the point O, it actually means they're talking about origin over here. Okay, so that means A is somewhere over here. A is somewhere over here. This is where A is. Okay, they said at noon A is point O and B is 10 kilometer due west of O. This is east. You know, right side is east, left side is west. Okay, up is north, down is south. Arrow. So now, so minus 10i. So this is where the B is. B is somewhere over here. A is somewhere over here. Boat A. So this is where the boat A is, and this is where the boat B is. Okay, boat B. Okay. Yeah. So now then they said, yeah, and the T hours afternoon. Okay, this is at 12 o'clock. This is at 12 o'clock. 12 o'clock is the when the time starts. Basically, T is equal to 0 is 12 o'clock over here. 10 kilometer due west of O. At the time T hours afternoon, the position vector of A and B relative to O is A and B kilometer. So this here we have to use that formula. R is equal to R0 plus V into T. If we want to know where an object is, given that we knew where the object was, this is initial position vector, and this is at what speed it is moving at, we can actually find where is that object going to be. This is final position vector, where that object is going to be after noon at certain time t. So I know their velocities, I know their initial position vector. Let's talk about A. Okay, final position vector of A. Final position vector of A is initial position vector of A, which was 0 because A is at origin. So 0i plus 0j. Indirectly it's 0 only. Okay, plus velocity. What is the velocity of A? If you see the question, velocity of A is 9. Is it J? Let me just see. Is it J? Yeah, it is J. Okay, 9J. So can I write 9JT because velocity into time? So this is your position vector of A. Let's go to position vector of B. If we go to position vector of B, the initial position vector So position vector of B, yeah, minus 10i plus velocity into time. What was the velocity it was moving with? 3i plus 5j t. So if you scroll down and if you make I and B common, so RB is going to be minus 10 plus 3 ti plus 5j t. Okay, so this is the position vector of A, position vector of B at in afternoon. So B part is done. Now let's go to C part. Okay, now in C part they said find the time when B is due south of A. So we have to find when B is due south of A. So let's say for example, what's okay, the A was moving at 9j kilometer per hour. So A was moving 9j. So basically A was here after time t, or here, or here, or here. Now we have to find when B is due south of A. So most probably B will be south of A, somewhere over here, down south of A, goes down south. Okay, if B is south of A, you know their J value is going to be no, their I value is going to be same and J value is not going to be same. Like for example, if let me change the color. If let's say A is over here, or let's say A is over here, let's say this is just an example I'm giving. It has no relation with this question. And let's say B is over here. Can you see both of their, if you draw a line over here, can you see both of their J value is differing? Okay, Y axis is differing, J value is differing. Can you see J value differs? This one, but their I value remains the same. So that's what happened when something is north or south of something. Okay, so in this case they said B is south of A. That means whatever I value A has, same I value B also has. You can see that in your question A's I value is literally 0. A does not have any I values. Okay, so A's I value is 0. What is B's I value? B I value is this. So can I write B's I value is also going to be 0? Because as I said, when something is south, their I values are same. So I value of B, this we are doing D part, no, C part. So B's I value is minus 10 plus 3t and A's I value is 0. So therefore 3t is equal to 10, okay, and t is equal to 10 by 3. So this is the time at which B will be south of A. Now we have to convert this to hours. How much is 10 by 3? 10 by 3 is around 3.33. 3.33 hours. Okay, so 3 hours, that means 3 hours plus 0.33 into 60. I'm converting these decimals, they are in hours. I'm converting them to minutes because 3 hour plus 0.33 hours. So 3 hours is 3 hours, 0.33 hour is 0.33 into 60, 0.33 into 60, that's around 20. 3 hours 20 minutes. That means 3 hours 20 minutes after noon, after 12 o'clock. Okay, they will be, B will be south of A. Okay, I hope you guys understood this. That's around 12 15 hours, 15:20, around 15:20 if I'm not wrong. Okay, now that means, okay, yeah. Now let's go with D part. At time t hours, the noon, the distance between A and B is given by this kilometer. Find an expression of A to B. If they ever give you find an expression of A to B, it's going to be B minus A. That means position vector of B minus position vector of A. So what was the position vector of B at A? This is the position vector of B. This part is position vector of B. So let me write that down. Minus 10t plus 3i minus 10 minus 10i plus 3ti plus 5jt plus 5jt minus, because there is a minus sign, minus position vector of A, which is this 9jt plus 9jt minus plus 9jt. So let's add them all. Now jt will get minus, so 10i plus 3ti it's going to be minus 4 JT. Okay, 5, 6, 7, 8, 9. Yeah, minus 4 JT. Now, so they said what to find? The D, the distance D. Remember, this is distance or displacement? Distance. What we got here is a displacement between AB. What we got here is a displacement between AB. So therefore I need to convert to distance. Now distance to displacement, we have to find the magnitude. And magnitude of AB is, that is, we can take magnitude of AB to be D, that is distance. Okay, okay, this is displacement, this is distance, the scalar quantity of it. So we can do 10 plus 3t square plus minus 4t whole square. So if we open the bracket from here, because it's going to be long, let me bring this root here and make it square. Basically squaring both the side, if you want to do that way also. 10 square plus 2 into 3t into 10 plus 3t square, I'm opening this bracket now, plus 16t square. Okay, so if we do this, we are getting 10 square plus 10 square is 100 plus 3 to the 6, 60t plus 9t square plus 16t square. Okay, now if we do that, 16 plus 9 is 25. Okay, so 25t square plus 9t square plus 60t. Okay, let me see whether it matched. They gave a minus sign over there, so maybe somewhere I made a mistake. Let me find that out. Okay, okay, I'm sorry for the mistake I made here. Actually I did not give minus sign here previously. So minus sign, there is a minus sign here. Minus 10 square is giving me plus 100, but it's going to be minus 2 into 3t into 10 if you open the bracket. So it's going to be minus 60t. So minus 60t. Another thing I by mistake I wrote is 9t square, I wrote here, so that was wrong. Okay, whatever. So now I think our answer is exactly matching theirs. Our answer is exactly matching this, whatever they said us to prove. So 25t square minus 60t plus 100. Can you see? Hence shown d square is equal to. If you see the question, that is the answer they wrote over there. Okay. So now they said at noon the boats are 10 kilometer apart. Okay, so the distance between them is 10 kilometer. Find the time after noon at which they are 10 kilometer apart. Very easy. We have to just use this formula. We have to just use this formula. Let me just increase the width of this thing. This is, we are doing, I think, D part if I'm not wrong. No, E part. We are doing E part. In E part, they said they are 10 kilometer apart, right? So 10 kilometer, in place of distance, you write 10 square, 25t square minus 60t plus 100. We have to find the time at which they are 10 kilometer apart. Yeah, afternoon. Find the time afternoon. Okay. So that means 10 square is 100 is equal to 25t square minus 60t plus 100. So 100 and 100 gets cancelled. Let's take t common and write 25t minus 60 is equal to 0. Therefore t, okay, so t is equal to 0 or 25t is equal to 60. T is equal to 60 divided by 25. Let me see how much is that in calculator. 60 divided by 25, that is 2.4. That means at 2.4 hours later, afternoon. So that's going to be most probably 12, 14 and 0.4. It's all in hundreds, right? So if 100 is giving me 1, because 14, 15, 16, you know, like that, 1400, 1500, 1400, 1500, 1500. So there is a 100 difference between them. Okay, so 1 hour difference means 100. So therefore at 0.4, how much difference is there? We can find that. So 100 into 0.4, how much is that? 40 minutes. So it's going to be around 12 o'clock plus 2 hours, so 14 hours, 1440. At 1440 they are 10 kilometer apart from each other. Hope you guys understood.